Everyone, am I audible?
Yes, sir.
Slide is visible.
Yes, sir.
Okay.
Yes, sir.
So in continuation of yesterday, we were discussing about the vertical alignment and about the valley and summit curve and what is the role of gradient and what are the design criteria we have as per Indian Road Congress that we have discussed. In continuation of that, the last portion, some of the small problems we can see related to the valley, how to design the summit curve and the valley curve with respect to the different criteria. So this is in a one way we have to identify the length of the summit curve. So we have that main deciding factor of the summit curve is nothing but stopping side distance. So this is we have discussed in the yesterday class what are the parameters are influencing when it is coming to the summit curve and when it is coming to the valley curve. So here we were talking about the comfort and overtaking side distance or the headline side distance, and when it is coming to the summit curve, the stopping side distance and the overtaking side distance playing the major role. So according to that, it has been given, so the length of the summit curve for the stopping side distance, when we are considering the stopping side distance, what will be the length of the summit curve. So for the identifications, what we have to do in the sense, we have the two kind of the assumptions. So the first assumptions, the length we are thinking that it is greater than SSD. So using this formula, so n into s squared divided by 2 into root of 2 into h plus 2 into root of small h the square. So the capital H is indicating the height of the driver, which we already know that it is a 1.2 meter. At the same time, the small h is indicating the height of the object which is existing. So that is nothing but 0.15 meter. So when you are trying to apply this 2, you might be getting the value of the 4.4. So the n is nothing but the deviations angle. Okay, the gradient might be there, 4 plus 4 will be there, and it is going to the minus 3. So what will be the algebraic deviations between these two? 4 minus of minus 3. So 7. So the 7 percentage we are considering as an n value. That S is nothing but the value of side distance, stopping side distance. When we are applying, you are checking the L value is greater than SSD. The assumption is it is confirmed based on that value what we are getting. In case if L is less than SSD, then we have to go for the second equations, case 2, that is the 2s minus 4.4 divided by n, and you have to apply that one and you might be getting what will be the length of the summit curve. So this is a two cases when the problem is asking with respect to the stopping side distance. So the case 1, you are applying and you are checking the assumptions, length is greater than SST. If it is confirmed, then the length what you estimated, that it's the finalized one. In case if it is failed to these assumptions, then we are moving to the second assumptions. Based on that, the equation is given. When we are applying with respect to the stopping side distance and the deviations angle between the two grade, so that is the length of the summit curve. At the same time, I told that the another factor is nothing but OSD, overtaking side distance. So for that also we have this equations, n squared divided by 8 into h is nothing but 1.2 meter. Here the object is not there, but the height of the driver is considered when it is coming to the overtaking behavior. So the first assumption is length is greater than OSD. If the assumption is fine and it is proving the length is greater than OSD, then you can finalize the length of the summit curve. If it is not, you go for the case 2, and this is the respective equations. When you are applying, you come to know what will be the length. So this is with respect to how to identify the length of the summit curve by considering stopping side distance or the overtaking side distance. So the problem, they will be giving the clear definitions whether you have to estimate the length by considering the stopping side distance or the overtaking side distance. Some questions sometimes they might be asking the both case has to be considered. So according to that, you have to estimate that particular value. So this is with respect to the summit curve. The same time, it is coming to the valley curve. So valley curve, what it is considered in the sense, the yesterday I told that the comfort is playing the major role when it is coming to the valley type of the curve. So the comfort of the driver is estimated with respect to the deviations angle, rate of change of centrifugal acceleration, the C value. Yesterday we have seen in the problem 80 divided by 70 plus V. So as I initially told that the IRCs recommended that value lies between 0.5 to 0.8, but the standard we can take it as a 0.6. This is a standard value. V is nothing but the speed of the vehicle in kilometer per hour. So when you are trying to apply, so it is in that particular equation. So the equation is nothing but 0.38 n v cube the whole power 1 by 2. So this is an equations for the identifications of length of the valley curve by considering comfort conditions of the driver. So which ultimately depending upon the deviations angle, rate of change of centrifugal accelerations and speed of the vehicle. If the problem is not given the C value, you directly take the value of 0.6. In case C value is they have a given maybe the 0.7 or something 0.8 other than the 0.6, then you have to use this particular equations where you have to apply the value for the C. Okay, so either use this one or this one according to the given data. So this is the estimations for the length of the valley curve for the comfort condition. The second important parameter is that the headlight distance, since it is going down and coming above, the length of the valley curve is ultimately depending upon the headlight distance, how much it is covering, which ultimately impact the side distance of the driver. So for the headlight side distance, we know that that is nothing but the stopping side distance. So this is we already seen one problem. What is the equations for the IST? What is the equations for the SST? So SST, it will be the twicer than when we are multiplying 2, you might be getting the intermediate side distance. But when it is coming to the headlight side distance, which is nothing but the safe stopping side distance. So that is the reasons here the same assumptions we are taking. Length is greater than SST. So we have the equations with respect to the deviations angle and the stopping side distance. If it is satisfying that assumptions, then it is fine. If it is not satisfying, then you can go for the second one, and this is the revised equations. So here you can estimate and what will be the final value. So that is considering as an length of the valley curve. So this is a four typical what we can say way we can design the length of the vertical curve. So it might be the valley curve or it will be the summit curve. So mostly the summit curve is depending upon the SST and OSD. And when it is coming to that summit valley curve, so it is depending upon the comfort level of the driver and headlight side distance. So the headlight side distance is nothing but SST. So according to that, the calculations are happened. So all these equations, first we are assuming that the length is greater than SST. If it is satisfying the conditions, we are finalizing with respect to the length. If it is not satisfying, so we have the second case, length is less than that SST. So according to that, the equations can be picked and it can be applied to estimate the final length of the particular value or the summit curve. So it is very simple. So mostly the data might be given. If it is not given, the link will be there. According to that link, you have to estimate that particular length. So this is the overview about the things. In continuation of that, so one more thing, it is there, the grade compensation. So in the horizontal curve, due to the turning angle of the vehicle, the curve resistance developed is equal to T into 1 minus cos alpha. what happened? So just imagine that one horizontal curve is there. Okay, one horizontal curve is the turning. In that turning, we have that vertical, what we can say, gradient also. So the horizontal curve is there. So we are providing that super elevations. The gradient is provided. Also here the vertical curve is as a vertical gradient we have observed. So there also gradations will be there. So when the two gradations will be there, so we cannot provide two, right? So it will be over, issues will be there, overturning or some other issues might be happening with respect to the frictions or the fractions or resistance issues and so that time what we are doing in the sense the grade compensations we have to do it, which allow the maximum value of the gradient at that particular location. So that maximum value generally we are taking as an ruling gradient. So the grade compensations are happening and IRC is defined, what we can say, the grade compensation is the reductions in the gradient at the horizontal because of the additional tractive force required due to the curve resistance. So that means in the horizontal curve, we are already providing the gradient. That gradient reduction supposed to happen because we already providing the gradient with considerations of the vertical alignment. So the IRC is specified the grade compensation is not required when the grade is going to lesser than 4%. Okay, it's not required for grades flatter than 4 or the less than 4%. Okay, if it is going more than that, what we have to do in the sense we have to take the equations 30 plus radius divided by r. R is nothing but the radius of the curve. So this is the percentage we were taking. So the grade compensations calculated by using these equations. Also the maximum grade compensation is limited by 75 by r percentage. So which one is coming to the maximum one? So that can be estimated as an grade compensations value. So probably when you are solving one equations or the one problem, so you might be getting what percentage we have to provide. So this is with respect to the grade compensation. So we will see maybe one problem with respect to the grade compensation. So mostly this kind of the scenarios are observed when it is coming to the hilly stations only. So this is the problem while aligning a hilly road with a ruling gradient of 6%, which is ultimately greater than 4%. So there is a need to provide the grade compensation. And the horizontal curve radius is 60 meter. Find the compensated gradient at that particular curve. Okay, so the ruling gradient is nothing but 6%. Radius of the curve is given as an 60 meter. So the grade compensation in the previously I have told that two steps are there, grade compensation. So 30 plus r divided by r. So 30 plus r is nothing but 60 divided by 60. So you will be getting the grade compensations value. At the same time, maximum limit of grade compensation is nothing but 75 divided by r. 75 divided by 60. So which is the value we were getting? So sorry, the lesser value we have to adopt when it is coming to the compensation. So we are comparing the both value. So which one will be the, we are checking. So whether it is coming less than the maximum limit, that can be accepted. In case if it is going more than maximum limit, and what is the maximum value you are getting, that you have to adapt it. Example here, if you are getting 10 and here you are getting 12, ultimately the 10 is less than the maximum limit, so you have to adopt the 10. Suppose it is 13 but it is going beyond the maximum limit, so that case what you have to do in the sense we have to finalize the value for the 12, not 13. So this is the way we have to identify the grade compensation. So if you are estimating for this particular problem 30 plus 60 divided by 60, I'm getting the value of 1.5%. and the maximum limit is nothing but 65 divided by 60, 1.25 percentage. So this is ultimately more than the maximum limit. So the grade compensations is value is nothing but 1.25 percentage. The ruling gradient is already given as a 6 percentage. Then the final compensated gradient is nothing but the ruling gradient minus the grade compensations what we have estimated. So we supposed to provide the 6 percentage, but by we need to apply the grade compensation of 1.25 percentage. So the final value will be the 4.75 percentage. This is the gradient we supposed to provide on the field instead of 6 percentage. So this is one simple example with respect to the grade compensations. So in the problem, you check the ruling gradient whether it will be less than or equal to 4 percentage, then nothing is required. If it is going more than that, we are estimating the grade compensation using the 30 plus r divided by r the equation. Also, we are estimating the maximum limit of the grade compensations. So whichever is coming within that maximum limit, so that we are finalizing as a grade compensation. For the applications for applying the final alignment on the gradient level, we have to estimate what is the compensated gradient. So which is the nothing but the difference between the ruling gradient minus the grade compensation, the final percentage what we are getting. So this is we supposed to provide in that particular horizontal curve which considering the grade compensation. So this is a simple problem for estimating the grade compensation. In continuation of that, we will try to solve the problem related to the valley curve and the summit curve. So this is in a problem. A vertical summit curve is given formed at the intersections of two gradient plus 3 it is plus 3 it is going, then minus 5 it is descending, ascending and the descending. So this is in a summit curve, vertical summit curve. Design the plus 3 it is going and minus 5 it is going on. Design the length of the summit curve to provide the SST for a design speed of 80 km per hour. V is given 80 km per hour. Assume any other data as per the IRC standard. So it looks like a simple problem, but it a little bit of the lengthy one. So in that summit curve design, they have clearly defined we have to solve with respect to the SST. Okay, so with respect to the SST, we have to estimate the length of the summit curve. There is a two case. I told that the first case is length. We are assuming greater than SST. If it is final, then finalize it. If it is getting not satisfying the conditions, then length less than SST assumptions we are taking. We are applying the equations and we are estimating. So let's go for the case 1. The assumption is nothing but length is greater than SST. The equation is nothing but length equal to n into s squared divided by 4.4. So the n is nothing but I told that the deviations, algebraic deviations angle between the gradient. So plus 3 minus 5. So 3 plus 5, 8. So 8 percentage, but it is not applying in the percentage. It is the value. How many 1 and x, how many things we are applying. So the n is nothing but 0.08. So this is the value is given as an n in your problem. Other than that, we supposed to estimate the SST. SST is nothing but stopping side distance, safer stopping side distance, which is not given in the formula. but you know how to estimate it. So the SST equation is nothing but the first class of second unit. We know the equation 0.278 into VT plus V square divided by 254. So what happened in the sense, the effect of the gradient SST is we are assuming that compensated. So we are estimating with respect to the given, what is that speed is given, and T we are assuming as an 2.5 second. If it is a OSD, so you assume 2. So here we are assuming 2.5 second, V is 80, F is longitudinal coefficients friction 0.35. It is not lateral. So if it is coming to the super elevation, then the value is 0.15. So this might be expected in some of the competitive exam. What will be the maximum limit of the coefficients of the frictions when it is coming to the lateral and longitudinal? This will be the longitudinal, this will be the lateral. So when you are applying all the value, you come to know what will be the SST. Then you can apply in your final equations. N is equal to 0.08 into what the S square value you are getting when you are applying, so that you are getting. So if the length is greater than what you have estimated in that SST, so then the case 1 is true. We can finalize what you have estimated here. So probably I will estimate 0.278 into 80 into 2.5, 55.6 plus 80 square divided by 254 divided by 0.35, 71.99 plus 55.6, 127.59 I'm getting. I'm just to make it rounding as a 128 meter. So when you are applying 128 meter divided by 4.4, oh sorry, this is square. Yeah, 128 square. 0.08 into 128 square divided by 4.4. I'm getting the value of 297.89. Okay, which is ultimately greater than 128. So the assumption is correct. So the final value for the length of the vertical summit curve is 298 meter. So this is a final value. So students, probably it might be simple. The vertical summit curve is formed at the intersections of the two gradient plus 3 minus 5 percentage they have a given. It is going plus 3 positively ascending order. Then it is coming to the negative minus 5. So this kind of the summit curve is formed with respect to the design speed of 80 km per hour. So the problem, they ask us to estimate the length of the summit curve by considering the stopping side distance. Okay, so the n is nothing but the algebraic deviations between the two gradient plus 3 minus 5. So 8 percentage. For the estimations purpose, we have to take it as a 0.08, not in the percentage value. The case 1, we are assuming length is greater than SST. If it is satisfied, then you finalize that length of the summit curve. If it is not finalized, you go for the case 2, length is less than SST. That equations you have to apply on the problems. So the first case we have taken with an assumptions length is greater than SSD, n into s square divided by 4.4. This is the equation where you need the value of s and n. N is 0.08, S is nothing but stopping side distance. You know the equation where you require the design speed, reaction time, longitudinal coefficients of friction. When you apply all the value, you get the value of 128 meter as a stopping side distance. So then you apply in that length equation, we are finally getting the value of 298, which is greater than 128. Therefore, it is satisfy our first assumption. There's no need to go for the case 2 and the final solutions. The length of the vertical summit curve is the 298 meter. So this is one simple problem how to estimate the value based on that SST. So in continuation of the same problem, the same pattern, the simple one is given the vertical summit curve is designed when the two grades. So they given 1 in 50 and minus 1 in 80 on the highway. The SST and OSD required are 180 and 640 meter respectively. But due to the site conditions, the length of the vertical has to be restricted to a maximum value of 500 meter if possible. Calculate the length of the summit curve needed to fulfill the requirement of SST, OST or at least intermediate side distance which is twice than SST value. So here what they have given in the sense the design speed is they given as an what it is given. So design speed, so they have not given the design speed. Okay, in that particular point of view, what we are doing in the sense, we are assuming it is on a highway with respect to the design speed of 80 kilometer per hour. So the mostly if the problem, the design speed is not given, we can take it as an 80 kilometer. So they given the value of n they have a given. So n 1 is nothing but 1 divided by 50, n 2 they have a given minus 1 divided by 80. So the deviations are how we are estimating n is equal to 1 divided by 50 minus of minus 1 divided by 80. So this is with respect to the n they have given. Okay, so the same problem what they have a given, they given the SST value as 180 meter and OSD is nothing but 640 meter. Okay, so this is the things they have a given in this particular problem. Length is what they have a given in the sense 500 meter. So length is they given as a 500 meter, SST they given, OST they have a given. Okay, then what they are asking in the sense, so they were asking the length of the summit curve. So we have to provide that has to be fulfilled the stopping side distance, overtaking side distance, or at least IST value they have a given. But the same time, what they have mentioned that the length of the vertical has to be restricted the maximum of 500. It should not be crossed more than 500. So that is they have a given. So the length is has to be restricted with the maximum value of 500 meter. So this is the things they have a given. Okay, so what you have to do in the sense with respect to the SST, length is supposed to be greater than SST. Length is less than SST. These two assumptions we have to check it. At the same time, what you have to do in the sense the length is should not greater than 500 meter. So this criteria also we have to check it. At the same time, you know the equations for the overtaking. So the length is supposed to be greater than OSD. The length is supposed to be less than OSD. So these two assumptions we have to check it. But if you are seeing the OST value is 640, 640 is ultimately greater than 500. Okay, so then what is the thing in the sense this case is not possible. If the length is more than OSD, it might be 650, but our case is we supposed to restrict to the length is maximum of 500. So ultimately this options rule out. Okay, so only one case we have to check it, length is less than OSD. So all these assumptions we were checking, then finally which one will be the maximum one. So that case we are trying to finalize as an what we can say, finalize as an length of the summit curve. So students, I'm not going to solve this problem. It is the same pattern what we are followed in the previous one, but little bit detail they have a given with respect to the data. So what happened, they given the n1 n2, at the same time they given the SST OSD. Okay, no need to estimate by yourself. Sometimes what happened, the previous problem like SST OSD they won't give, you have to estimate, you know the equations, so you have to estimate it. But in here they have given directly, at the same time they explain that the maximum length is restricted with respect to the 500. So all these possibilities we have to check it. The length is greater than OSD. Length is OSD is nothing but 180 meter. So then there is a chance it is greater than 180. At the same time there is a chance less than 180. The same OSD also we were comparing, but it is 650. It's supposed to be not greater than 650 because the maximum is restricted of 500. So when you are applying only one cases for the second one, length is less than OSD. Out of this, which one is the maximum length which supposed to be less than or equal to 500 meter? So that can be the finalized length of the vertical summit curve. So this is the things with respect to the vertical summit curve. I request the students you try to solve by your own. So this is with respect to this particular problem. At the same time, the same case it is given for the next problem. We can see valley curve. So how the details are given. So the valley curve also the same pattern. Okay, the same things we are going to follow it. They given the descending grade. So it is the descending 1 in 25, and again it is ascending 1 in 30. Okay, so that means minus 1 divided by 25 plus 1 divided by 30. This is n1 n2. So n1 minus n2 when you are putting, so you will be come to know the value of n. At the same time the design speed is given. The problem itself they given a assume the centrifugal acceleration c value as a 0.6 meter per second cube. Then they have specified the two criteria with respect to the comfort conditions, with respect to the headlight distance, estimate the both value. So for the comfort conditions, you have the equations L is equal to 2 into n into v cube divided by c, the whole divided by 1 by 2. So this is the equation is not specified. This is with respect to the meter per second. So you can convert to the 80 to the meter per second. Else with respect to the kilometer per hour, the equation is given. So that same you might be adopt. Any one equations you can take it and you try to apply the n value, v value and c value. So you come to know what will be the length with respect to the comfort condition. At the same time, the headlight side distance, I told that there is the two cases. Headlight side distance is nothing but equivalent of the stopping side distance. First case is it is greater than SST. The second case is it is less than SST. So we have the equations L is equal to n squared divided by 1.5 plus 0.035 into S. S is nothing but the stopping side distance. So SST is not given in the problem, but you know the equation for the SST using the design speed, the coefficients of the frictions, then the reaction time, you will be estimating the SST value and you apply that N and S value, you come to know what will be the length of the transition curve. For this particular problem, it will satisfy the case 1 itself and you will be getting the final value for this particular problem. So this is with respect to the valley curve where we are considering the comfort of the driver. For that only one cases are there. There is a no two cases. So with respect to the one equation you estimated headlight distance, there is a two probability greater than SST or the less than SST. So apply according to that equation. Then out of this two, which one is satisfying? So that will be the final length. So based on that, you are checking which one is giving the maximum one. So according to that, you might be choosing the final one. So probably here you might be getting the 180 and here you might be getting the 280. So the maximum one is 280. So this will be the final length of your valley curve. So this is with respect to the valley curve. It is very simple and the straightforward problem. At the same time, the OSD, with respect to the OSD, how to estimate, that has been given in this equations, which is exactly similar to the second problem what I have shown it. So this is the things, and this will be the ruling gradient, which I already shown the results how to solve this one in the previous slide itself. So this is with respect to the vertical alignment. Yeah, this is the same problem only. So 6% rolling gradient, 60-meter radius, find the compensated value. So which we already estimated here. Yes, here I'm concluding our second unit. So a little bit lengthy, I understand, but probably I try to cover with respect to the little bit interest. Hope you might be getting that knowledge in the field of the highway geometric design. Still, I have circulated the materials, and the today materials also I will finalize and I will put in our MS Team groups. So you go through all the materials of the second unit, including the problem. So where we covered initially we have started